Alright, so the first criteria of Darren's question is, right, he's looking for 4 up bars in a row. Right, so we have 4 up bars in a row, and then next he's looking for 4 down bars in a row, like so. And then also what's needed is a little wick on that reversal bar there. So yeah, that's why actually this over here doesn't qualify, because there's no wick on that reversal bar. So and then so in this situation, right, we're looking for up bars, then down bars, and then a long signal is going to be generated here. So we actually want a long trade signal right there on that 4th down bar. Right, so that's what we're looking for. So there's 3 components here, right? We're looking for 4 up bars in a row, then we're looking for 4 down bars in a row, and we're also looking for a wick on this reversal bar here. All right. So, all right. So that's going to be the first question for today. All right. So let me close some of this out of the way. All right. So with BloodHound open here, the interface. Let me give this a name first. All right. So just put today's date in there, the 15th. Save it. Okay. So first thing I'm going to start doing is I'm going to start working on the logic template here. And so there's no logic templates defined yet, so I need to click the new button here. And now I have a new logic template to work on. So I need to kind of come up with some kind of a name here. So for the lack of a better name, I'll just call it 4 up and 4 down. Let's see, with a wick. All right, with a wick. Okay, so criteria, 1, and I guess I'll call this criteria 1 and 3. So criteria 1 is 4 up bars, criteria 3 is 4 down bars, and criteria 2 will be looking for that wick on the reversal bar. So if we're looking for bars in the same direction, we can use the bar direction solver there. So alright, so with the bar direction solver, I'm actually going to have this look for 4 bars. And so to look for 4 bars in a row, right, I'm going to set the number of bars to 4. And I'm also going to set my mode. I'm going to change it from %. So you can see in percent you kind of get this little wave kind of look, this analog kind of look, and I'm actually going to change it to all or none, and you can see that gives me a cleaner look there. So and so we can actually see this is actually the 4th up bar in a row. If we count them, this is the 4th one being marked. And this other up bar, also if we look back, this has 4 up bars as we look back as well. So, alright, so there's the first criteria. Now keep in mind that what I have identified on a chart is going to generate a long signal here, right? So when we look for the 4 down bars, I need those to actually be a long signal here, right? So you can see that the solver is actually generating a short signal here, but I actually need a long signal here on this bar from my bar direction solver. So what I can do is I can use the long short modifier to change this here. So, however, I'll get back to that in a moment. So the first thing I need to do though is, right, these 4 up bars that are giving me a long output, right? I need to get the signals from here. I need to get them from here over to this bar. Remember, this is the bar that the trade setup actually finishes on, right? So this is the bar where all 3 criteria are completed on. So I need to get this long output here over to this bar. So the way I can do that is I can use the lookback function node. So this lookback function node, right, it has a displacement and a lookback period. So if you just want to shift, if you want to take your signals and just shift them forward a fixed number of bars, we're going to use this displacement feature, right? So this displacement feature is the same thing as NinjaTrader's displacement. So if we open up my indicator window, right, this is the Ninja indicator window, and I'm looking at the stochastics indicator, and you can see this, right, it has a displacement function here. The MACD has a displacement function, right? All indicators have this displacement parameter, right? This is a NinjaTrader feature here. So the lookback node in BloodHound also has that displacement, and what we want to do is displace it forward 4 bars. So let's take a look at what that's doing there. Alright, so now you can see that, right, those 2 long outputs now have been pushed forward onto the bar that actually has where our trade signal is wanted. Alright, so we've got, so basically that's criteria 1 has been met, right? So once again, criteria 1 is looking for our 4 up bars, and we've gotten the output from our 4 up bars shifted forward onto our actual bar that where the trade signal is going to be. Okay, so now let's see. Actually, okay, I'm going to take a slightly different approach here to this, just because I think it's going to be easier to comprehend, and then I'll go back and kind of show you a more streamlined way of building this. So, alright, so the next step here is I'm going to build condition 3 where we're looking for 4 down bars, right? So let me grab another bar direction solver, like so. And once again, this is going to be looking for 4 bars. Alright, and we're going to be looking for 4 bars in a row. So this solver is going to be set up exactly the same as this one here. Okay. So what we're looking at now is this bar here, right? So we have 4 down bars, right? And the bar direction gave us a short output, right? Because they're down bars. So we need to actually reverse this. So when we find 4 down bars, we need to actually reverse that because we want, remember, we want a long trade signal here. So the way we're going to reverse this is you don't want to use the invert, right? If we use the invert, you can see this kind of gives us a really kind of crazy output there. So we don't want to invert it. What we want to do is reverse it or swap it. So this long short modifier, its default mode is set to swap. And so if we take a look at it, what comes out of there, right? Now look, now this what was a short output now got reversed or swapped to a long output, right? So now that agrees with the long trade setup that we want to build here. So, all right, let's see. I'm gonna just shorten this name here. It's an awful long name, so I'm just gonna shorten it to swap, since that's what it's doing. And you can see it makes this solver a little bit shorter as well. All right, so a little easier to work with. All right, so we have condition 1 and condition 2, and so now let's use an AND node here, and we're going to join both of these together with an AND node. All right, because condition 1 and condition 2 both have to happen. So that's why we're going to use an AND node. So, and let's see. You can also make a little note here that this is basically kind of using the number 1 to denote that this is like for condition number 1, and number 3 to note that this is like condition number 3. So I connected my AND node to the result, and let's take a look. So look, we have two signals here, and look, we actually have a short signal here, which looks correct. Well, actually, it looks correct because we do have 4 down bars, and then we got 4 up bars to generate this short trade signal right here, right? However, we are missing a wick. Remember I pointed out that we're missing a wick on this. So we haven't built condition 2 that looks for that wick yet. So that's why we actually get this short trade signal. So, all right, so the next step is we will look for this wick, and this wick needs to be on the reversal bar. So it's actually going to take a couple of solvers to make sure that we're only looking for wicks on the reversal bar here. Right. All right, let's let me straighten out my chart. There we go. All right, so we know that the wicks need to be on a reversal bar. So the first thing I'm going to use is a inflection solver. Right, so the inflection solver looks for changes in direction, or basically it looks for a reversal in direction. As an inflection applies to a chart, you're looking for a reversal in direction. And we're actually going to look for price reversing in direction here. So what I'm going to do is I'm going to take the type, and I'm going to change it from an indicator value to price, and you can see that it defaults to the closing price. So we're just going to look to see when the closing price reverses direction. So as we look at the chart now, we can see whenever the bars reverse direction, right, we get an output in that direction. So for example, right here on this bar, right, with a green long output, it's because price was moving down and then it reversed up. And over here, this red painted bar, right? Price is moving up and then it reversed down. So that's what that inflection solver is doing for us, telling us when price reverses. So I'm going to rename this. So we're actually looking at the close price. All right, so there's kind of the first part of condition number 2. So we've identified this reversal. Now you'll notice that it's actually given us a short output. So we're going to have to swap that short output for a long output, right? Because remember, this ultimately is to build a long signal here. So we need to swap that or reverse that short into a long. So let's grab another long short modifier, connect that up like so, and I'll change the name here like so. Alright, so let's take a look at the original inflection solver here. And once again, I just want to demonstrate, we don't want to use the invert. If we do, that's what we get. We actually get a true inversion of it. And that's not what we want, because if you look at the output here, we're getting lots of longs and lots of shorts, and that's not what we want. So invert is different than reversing or swapping your signals. Let's turn that back off. Take a look at that. So there we go. All right, so we have this reversal bar, and we've identified it with a long output for now. Okay, so the next step is we need to look for the wick on this bar. And let's see, to look for the wick, what we're going to do is make a comparison. We're going to compare the high price of the bar, and we're going to compare it to that would be the open of the bar. So we're going to make sure that the high price of the bar is greater than the open. Right? So if obviously the high, a wick only happens when the high is greater than the open, right? If the two are equal, then there is no wick. And we're also going to do the opposite as well. So, right, so let's say, we almost got a short signal here, but we didn't get 4 down bars in a row, unfortunately. But I do have a reversal up bar that has a wick. So we can use this as an example. So we're going to compare the low price of the bar to once again, the open of the bar. And we want to make sure that the low of the bar is less than the open. And that tells us that there's a wick, as long as the low is less than the open. Right? So obviously when the low and the open equal each other, then there's no wick. Right, so these are both comparisons here. We're comparing the high to the open, and we're going to compare the low to the open. So let's grab a comparison solver here. I'll drop that down here. And let me adjust my chart a little bit. There. Right, it's always handy to have BloodHound on one side of your monitor and then have your chart on the other side of your monitor. So that way you can watch the chart as you're building your solvers. So what this solver is doing is it's comparing the high and the low to the open. So we need both indicator A and indicator B to set to price. We need indicator A and indicator B set to price. So let's change our type to price, and we'll change our type to price, like so. And let's see here. Yeah, so I'm going to set the high and the low prices up here, and set the opens in indicator B. So let's see, yeah. So looking at this again. So remember this example, or this section of the chart that we identified, we want to generate a long trade signal. So when the high price of that bar is greater than the open of the bar, we want to generate a long signal there. So for the price type long, we're going to use the high, and for the short, we're going to use the low. Right? And so remember, over here, if let's say, yeah, over here, if we had 4 down bars, then we'd actually get a short signal here, because we did have a wick. So, but this is a good example of using a reversal up bar to find those wicks. And so the low, so the low price compared to the open is what's going to generate a short signal in this situation here. All right, and so the next is we're comparing the high and the low to the open price of the bar. So I can just change both of these to the open price, like so. And let's see. All right, let's see, I'm not quite getting what I expected. So and actually that's okay. Yeah. Yeah, we're not quite getting what we expected, and so let me kind of explain what's going on here. Actually, let me just analyze this for a second. Yep, sometimes even I need to pause and think about the logic of putting a system together here. Okay, yeah, actually, what we're getting is correct. So, if we take a look at one of these other bars here, right? Here's the open, and here's the high. And, right, so the high is greater than the open. And, okay, so what we need, if we want to see this correctly, what we need is a bar direction solver in here to actually see this correctly, and that's because this bar that I'm using as an example to illustrate the high being greater than the open. So this is a down bar. Now of course on every up bar, the high of the bar is always going to be greater than the open. So that's why all of these up bars, all these up bars have been marked with a long output here. If you look at BloodHound's output, so, and of course all these down bars with wicks have also been flagged with a long output. So that's correct. So yeah, in order to see this correctly, we'll need a bar direction solver, like so. And let's see, yeah, I believe, yeah, I think this time I can actually invert it. And if I use a AND node, there we go. Yep, and there we go. That cleaned it up. So we can see whenever we get an up bar with a wick, right, we're getting a short output. That's essentially what we're looking for. And whenever we get a down bar with a wick, we're getting a long output. So remember, keep in mind, so we have condition 1 is 4 up bars, condition 3 is 4 down bars, and condition 2 is looking for this wick on this reversal down bar. Remember, so this is a reversal down bar with a wick, and so we want to identify that with a long output. So all these down bars with wicks have also been identified with a long output. And so the key to filtering this out is using that inflection solver. So remember, previously we had built this inflection logic here, looking for these reversal bars. So if I plug this into that AND node, there we go. So now we've identified this reversal bar with a wick. And once again, we identified this reversal up bar with a wick. So we can see only reversal bars with wicks are identified. So if we take a look at this bar, right, this reversal up, there's no wick and it's not identified. So we can see it took, a couple of different pieces of logic to get this filtered out correctly. So when you're building your system, right, you want to look at each of the individual components separately. It's natural for our minds to look at this, this reversal bar with a wick as one condition, but it's actually not. It's a whole bunch of conditions that had to be joined together. But our minds are capable of doing visual analysis like this is one simple condition to us. That's how our minds operate. But a computer, you kind of have to break down each of the little components to identify something like this. All right, so this AND node is essentially condition number 2, like so. All right, so we have condition 1, condition 2, condition 3, and then condition 2. So what I can do is take this, connect that in there like so. So before I connect this in, before I connect it in, remember what we want to get rid of is this. We want to get rid of this long signal because there was no wick. Remember, there was no wick on this reversal bar. So adding in condition number 2 is going to get rid of that wick, right? Because if we look at condition 2, we can see there's no signal there, right? But we do have an output on this reversal bar with the wick. So as I take this, connect it into my AND node, and voila. Oh, look at that. Oh, that's right. I forgot to do one thing. I'm missing one little component here. So remember, we got condition 2 working on the actual reversal bar. But if you remember, our trade signal is actually over here. It's right 3 bars afterwards, 3 bars later. So once again, we need to take this long output and shift it forward onto the final bar where where the trade setup completes, right? So we need to shift this long output onto 3 bars forward onto this bar where the trade signal actually shows up. So we can do that by using another look back. And once again, I'm just going to use the displacement function here, and I think I just need 3. And yep, 3 it is. So we can see this that long output that was on the reversal bar is now shifted forward onto the actual trade signal bar, like so. Alright, so now let's take a look, and disconnect that. We'll take this and connect it in, and there we go. So there is our long signal. And remember, on this bar there was no short because it was missing a wick. So, alright. So the next step is, once we think we have it working, once we think the logic's working, I'm just going to scroll through the chart here and see if there's any other signals that show up. No, there's another long signal there. Alright, so it looks like we do have 4 up bars and 4 down bars. Let's see. So we have 1, 2, 3, 4 up bars in a row. And we have 1, 2, 3, 4 down bars in a row, and there's a wick. So that looks good, looks correct. So we almost, we almost could have had, a short. We almost had a short signal there. However, the problem was that this was a doji. There was no. This actually wasn't an up bar. That was a kind of a down doji. So that kind of killed that. Killed that as being a trade signal there. Alright, there's another one. Another long. And that looks good. 4 up bars, a wick, and 4 down bars. So, alright, so I'd say that works pretty good. So, and let's see, when I started this off, I was going to show, yeah, so here's kind of what I wanted to show you, is a little shortcut in the logic, right? So both of these bar direction solvers are the same, right? They both are looking for number of bars 4, the mode is set to all or nothing, the invert is off. If I take a look at this one, once again, invert is off, all or nothing, number of bars 4. So I don't actually need 2 of these, right? I can actually disconnect that like so. Let's see, I think our trade signal was right there. I can actually take the same take just one of the solver, connect it into that swap like so, and there we go. So I can eliminate an extra solver that's really not needed, because they're both doing the same thing. So There. And next I'll need to do, so you'll notice when I deleted that solver off the board, it just took it off the board. It didn't actually delete it. So it still exists right here, right? So that was 4 bars, direction number 3. So it still exists. So if I want to remove it completely from the system so that it's not being calculated, right? So keep in mind that this solver is still being calculated by BloodHound in case you want to use it again. So if I don't want that to be calculated, I can just delete it off the board there, right? So I should probably kind of rename this a little bit because that's not just number 1 anymore. So this actually is let's see, I think that's condition number 1, and the swap was looking at condition number 3, like so. I can do something like that. Okay, now let me see if there's any questions on this, and then I'll move on to your guys' questions. Alright, so let's see. William was asking, can I use the inverter node to shift the signals? So let's grab an inverter node here. So, no, you can't use the inverter to shift the signals because you can see that there's no displacement feature in here. However, I can use the inverter node to swap the signals. So let's see, let's take a look here. Alright, so here's an inverter node, and you'll see that the inverter does have this swap option in it. And let's take a look at actually so here's kind of what it looks. So here's what the bar direction looks like, right? We got two short outputs, and we have 2 long outputs there. Now if we take a look at the inverter, right, it actually did truly invert. Right, it did truly invert. It didn't swap. So if you want to use the inverter to swap, you actually have to turn the invert off. So you can see this long side has an invert and short side has an invert. So I can, if I turn that off, so that turns off the inverting, right? So things are not being inverted anymore, right? So once again, I'm left with just, so right now the inverter is doing nothing, right? You can see that, right? Long output as before. If I take a look at the bar direction solver, right? Long output, short output. Take a look at the inverter, long output, short output. So obviously I need to take the swap and turn it on, and now you can see that right, the outputs were swapped or reversed. So the inverter can be used to kind of reverse your signals, but not shift them. So let's see. John wants to see what happens if we make a change to one of these comparison solvers here. Alright, so let's see. Alright, so this comparison solver here, right, that's looking for the wicks. Right, so we had this comparison solver that's comparing the high and the low. Let me find that on the chart again. There we go. Alright, so we have a comparison solver that's comparing the high and the low to the open, right? That's finding our wicks here for condition number 2. So let's see. John wants to see kind of what happens if we reverse these situations here. So I guess maybe what you're talking about is if we put the open up here in indicator A, and then we put the high and the low down here, and see what happens. Let's see. So we're not getting anything. So let's swap these around, see what we get. Like so. And here's something that might help you guys when you're kind of figuring out, how to set your prices up and whatnot. Is you can turn one of the outputs off. So if I take the short output, set all these to 0, right, it turns the short output off, and then that allows me to just kind of focus on just one side, one condition, the long side condition there. And let's see, it does look yeah, it does look like that actually works. Let's see, we'll take a look at the end node here. So yeah, it looks like that works as well. There's always kind of one way to, to build your logic here. There's always usually multiple ways to build your logic here. Let's see, what else? Oh, well, yeah, let me point out something else here. So, as I explaining this, it kind of helped to use this bar direction solver. However, this bar direction solver is really was not needed in this. If I disconnect this and take a look, we can see that it's all working out here. And the reason why is let's take a look at our comparison solver. Right, so remember, our comparison solver was giving us a lot of outputs here because the the open was always less than the high on these up bars. However, remember we created this inflection condition here, right? So we're looking for reversal bars, and so that reversal bar logic here would is filtering out all of these long signals here that we're getting. So I really didn't need a bar direction. That was just to kind of help illustrate, to kind of clean up this comparison solver when I was building it for you guys. But it's really not needed. So if I take a look at, the inflection solver and the comparison solver together, I can see that right, we only get a long output on a reversal bar, inflection bars here. And oh, actually, you know what? Look, changing the logic actually didn't work. Look at this. So yeah, it's actually not working correctly because here's a reversal down bar with no wick. So that actually isn't working correctly. So let me go put this back to the way it was. Change that to the open. Change that to the open. And there we go. Yep. Okay, so this reversal down bar with no wick is now removed. So, all right, so we'll just keep it the way it is. And as we found out, I didn't need this extra bar direction solver. I'll just take it off of here. And I also need to remember to turn my short output back on here. So, okay, so there we go. There's the reversal up with wicks, giving me that short. So, and then I'll just leave it on the actual final AND node there, the final one that gives us the signals. I got a simple question here from Andrew. So Andrew would like to know, how can you get rid of small reversals that have 2 or 4 something using the ProRenko? Okay, 2 or 4 bars using the ProRenko bars. Okay, so let's build that chart here. Let's see. Let me clean up my chart. There we go. Alright, so we're going to use the ProRenko bars here. If you don't have the ProRenko bars, obviously you could use the anaRenkos to look the same as the ProRenkos. And let's see, I'll build actually I'll build a 6-1 so I don't get a lot of bars. And just 3 days of data. There we go. Okay, so I guess there's a couple of examples there of some reversal bars that only have one or 2 reversal bars, like so. And let's see. So to kind of filter that out, I guess a couple of things that you can try. So let me make a new logic template to work on. Let's see. Okay, so one way you could do this, we could use the bar direction solver. Let's see. All right, I need to start. Let's see. I need to start with, I guess, some kind of a signal here. Yeah, let me just. I'll just build another inflection solver here, looking at the closing price. All right, so if we're just looking at just the reversal of the bar as our signals, and so essentially we kind of want to filter out all this choppy reversal stuff here, right, like so. So one way to do that is we can use the bar direction. So if you want to filter out, if you're filtering out like up to 4, then let's see, yeah, we'll need to set the number of bars to 5, and like so. And I'll set the mode to all or none. And so as we look at this, right, so we got this reversal up, and the first 4 bars, we can see there's no output, right, and then we start getting a long output. So we can see over here, we got all this reversals and there's no output until we finally get to the 5th bar. So that way we know that there's 5, at least 5 bars in a row of continuation, and it filters out all this reversing stuff. So alright, so remember, so I'm going to use this closing inflection as my trigger here. So this is kind of like my trade trigger, and you'll notice, right, I only get a long output right afterwards. Whereas if I use the bar direction solver, and let me give this a name first. There we go. All right, we can see the bar, 5-bar, direction. There's no output until we get to that 5th bar. So if we use an AND node, we're not going to get anything. Right? So we get nothing. So what we need to do is we need to take basically our trade trigger here, right, which is giving us a signal here, and we'll need to shift it forward onto this 5th bar here, like so. So there's a couple ways I can do that. One simple way is I can use this look back period, and I can set that to 5, and right, you see how now all 5 of these bars have a long output, like so. So basically I've taken this reversal up and shifted it, well, not shifted it, but actually extended it forward onto this 5th up bar here. So now if I take a look at the AND node, there we go, there's our long signal, and then there's a short signal. So we got 5 bars like so, right, 5 up bars, 5 down bars, right, and we eliminated any kind of signal from that chop right there. So that's one way to do that. So I guess another way you might be able to do that is to use a moving average. So let me just put a simple SMA on here. I don't know what period to use. You'll just have to kind of experiment to see what period works best with your system. Alright, so if we use some kind of a moving average, right, I can see that the moving average is sloping up, like so. So I could use this moving average as a filter to filter out all these down reversals. So let's take a look at that. Alright, so let me build a slope solver here. So I'll grab a slope solver and we'll have it look at the 20 period SMA that's on my chart. So right, we already have the SMA selected. Alright, so hopefully you guys have noticed that all solvers that use an indicator, they always default to the SMA 14. So you have to have some kind of indicator defaulted there. And so let's change that to 20 period. And we can see that, right, whenever the SMA is sloping down, we get a short output. Whenever it slopes up, we get a long output. So let me name my solver. All right, an SMA 20 slope. And so the next step is grab an AND node. And let's see, I'm going to need to build another inflection solver because I don't want to change that look back period to 5. So I don't want to change that back to 1. So let me just build another close inflection. Actually, I already have one already here on here with the look back period of 1. So I'll just use that one. And let's see. So to use that one that I've already built, I can go to existing nodes, and there it is. So here's that inflection solver with the look back of 1. And remember the other one, I renamed it. I called it trigger, so I know that one has the look back of 5. So let me grab this one. This is the one I want to use. All right, plug that in. Okay, so we can see we got a bunch of reversal signals there. So we'll connect both of these in like so. Let's take a look at this. So, this wasn't, I don't know, this wasn't a perfect example or perfect solution, but I'm just kind of going off of generalities because I don't have any specific information about what exactly we're working with. But this is another possibility of using a moving average. So at least we can see over here in this area, it did filter out all of those short reversals, those short down bars. So that's another possibility. So really, I guess those are two kind of the two examples there that I can come up with. So a SIF wants to see, wants to know how to, let's see, build this condition. Let's see. So he's using small triggers and large triggers. So small triggers and large triggers are, that's a term that comes from the next gen trading room. So from John Novak over at Next Gen. And so small triggers and large triggers are basically a moving average. They're a form of a moving averages. So let's see, a SIF would like to see, so when the small triggers is crossing the large triggers but not able to cross both lines of the large trigger, and reverses in another, and reverses. Okay, so SIF would like to somehow determine when the small triggers fail to cross the large triggers. Okay, all right, I think I got it. Yeah, so let me set my chart up with the indicators that we're going to be looking at. And so for this example, I don't have any proprietary indicators on here. But I do have the ANA indicators, and I believe, pretty sure these ANA indicators include the trigger lines. Let's see. All right, I think I found them here. So while I'm doing this, let me just kind of explain that. Obviously I can't show any kind of proprietary indicators on my system, right? Because that means they have to be licensed from somebody. So the only indicators I can show in this workshop are ones that are publicly available from either NinjaTrader's download area or Big Mike's public download area. Those are the only ones I can get to because because another complication that might come up is you will have to have the indicators installed on inside your NinjaTrader in order to open up these BloodHound templates. If you do open up a BloodHound template and you're missing an indicator, BloodHound's going to give you a bunch of error messages, which isn't going to break anything, but obviously, you wouldn't actually be able to look at the BloodHound logic using that missing indicator. And so what BloodHound will do is BloodHound will replace any missing indicator with the SMA 14. All right, so if you guys load this BloodHound template, let's see, yeah, let me just open up BloodHound again real quick. Right, so if you open up this BloodHound template and you're missing the anaTriggerLines, what's going to happen is BloodHound. So let me just add I'm adding a new threshold solver. So if you're missing an indicator, right, BloodHound's just going to replace any missing indicator with the SMA 14. Right, so remember, as I kind of explained before, that all solvers always default at SMA 14. Right, you have to have some kind of indicator placeholder in there. So if you're missing an indicator, BloodHound's going to give you a bunch of warning messages telling you that your indicator is missing, and it's also going to tell you that's going to replace that indicator with the SMA 14. So that's what's going to happen if you don't have this anaTriggerLines installed. Right. Okay, so let me put the anaTriggers on the chart. There we go. So that's weird. I don't know why those disappeared. Alright, so I'm going to have to put them on here twice. Let's see, so a SIF, remind me, I think it's 20 and 5, I think, are the slows. And I think the 80 and 20 are the fast. And okay, I'm just making the lines a little thicker on the chart. And let's see, there we go. All right, I think that works good. And I want to fade that SMA back into the background. There we go. Okay. And all right, so let's see. Yeah. Harry did a good job at building these anaTriggerLine indicators. So the next challenge is to find some kind of rejection. So we have to. So if you're gonna have to, define what a rejection is a little better here. I mean, so like, for example, is that a rejection? I mean, look, the small triggers tried to move up, and then they failed and crossed back down. Is that what you consider a rejection? Or let's find another spot on the chart here. Defining a rejection is definitely discretionary. I mean, like, was that a rejection? Was this a rejection? So, or maybe we could work, maybe something like this here. Let's see. Yeah, maybe something a little more closer like that is considered a rejection. So when you say rejection, obviously you have to really get down into the details of what a rejection is. let's see. So let's see. Sif, you had said. Let's see. You said yes before. Let's see. All right. So we're okay. So this one is good, or the previous one? Okay, the circle. All right. Let's get rid of that. Okay, so we're going to focus on this area right here. So what I can see on the chart in defining this rejection is that the small triggers actually crossed inside the large triggers and then failed. All right, so that building this is going to be different than than building this as a rejection. Right? So building this rejection, I guess what you'd be looking at is just, how close did the small triggers get to the large triggers, right? Because the small triggers didn't actually get inside the large triggers, right? They got close, so they got within proximity. So that that condition is different than what we see back here, where the small triggers actually went inside the large triggers, actually penetrated inside the large triggers, and then failed, right? So, yeah, let's see. Let's see. All right, so Sif would like to see both. All right, so then we'll just build the more generic one. Yeah, so this one's going to be more generic, where it just has to kind of get close. So we'll work on this one here. And so building this one should also detect this one here. All right. So the key to kind of looking for this rejection is that you're looking, right, we're dealing with 4 different plot lines, right? So the large triggers, you can see they have 2 plot lines, right? Let's see, a fast and a slow moving average. And the small triggers have 2 plot lines, right? A faster one and a slower one. So what we have to do is basically make a bunch of comparisons here. So we're going to have to compare, let's see, well, maybe not. Yeah, initially I was thinking we were going to compare both of the small trigger lines to both of the large trigger lines. However, we can probably get away with just comparing a couple of different lines here. Alright, so hold on, I'm going to set a couple of things up here, turn some auto scaling off so that way the chart isn't so small. Alright. And I'll get rid of the MACD and stochastics there. There we go. Alright. So we might be able to get away with just like comparing, right? So let's see, in this kind of rejection, right? The large trigger, if the large trigger is sloping down, then I think we only need to compare, let's see, one of these small trigger lines, right, to, let's see, actually, yeah, I'd say we probably need to compare it to both of the large trigger lines. Yeah. We'll kind of start with that idea here. right? So this definitely is going to take some experimentation to find out what works and what doesn't work. And that really is the beauty of BloodHound, is if you asked a programmer to program this for you, even the programmer would have to kind of go through various iterations to kind of see exactly what, which of these lines he needs to compare to and whatnot to get it to work correctly. So the beauty of BloodHound is that we can go through these iterations quite literally within minutes, versus having a programmer having to write the code, test it, and then rewrite the code and test it, which takes days and hours to do. So let's get BloodHound open here. Alright, let me start a new logic board here. Okay, so I'll just name this as moving averages, fail to cross. Because this logic could, I think the logic that I'm going to build here potentially could be applied, to any moving averages, because that's all the anaTriggerLines are, right? These trigger lines are just moving averages. So I'm going to need to start off with, let's see, definitely a couple of comparison solvers. So I'll just drop a couple on the board here. Let's see. Yeah, I think I'm going to need at least 4. Let's see. Alright, so the first thing I'm going to want to determine is, I want to check to see when one of the small trigger lines gets within a certain distance from one of the large trigger lines. And let's see, I need to look at the name of the plots here. Alright, yeah, so it looks like I have a plot name called average and the other one's called trigger. Yeah, so I think that the average is the slower moving one and the trigger is the faster moving one. So if we're looking at these large triggers, the slower one is going to be our average, I believe, and the faster one is going to be our trigger line. So, alright, so let's see, the first thing I'll do is I'll compare, let's see, the small trigger line to the large trigger line. We'll make that comparison first. Alright, I'm just going to have to use some abbreviations here. So I'm comparing the small trigger to the large trigger. So let's load up our indicators here. And so to define the small triggers, it's setting of 20 and 5. And I'm just comparing the trigger lines. So, and then later on I'll compare the average lines here. But all right. So once again, I'll set up indicator B to the large trigger line settings. Right, 80 and 20, the trigger lines. Okay, so that's the settings for the large triggers. And so now the next step is I actually need to clear the outputs because we're looking we're going to be looking for when, right, the two trigger lines get close to each other. So we're going to be using the A equals B here, like so. And so now, next step is we actually have to set a distance here, some kind of a distance. And yeah, so this distance is probably going to vary depending on what instrument you're using. So let's see, I'm using the YM, and I don't want to change my instrument because I don't want to have to find another spot. So alright, so let's just use 10 ticks on the YM. And maybe 10 ticks is a little too big. Let's try 5 ticks. Alright, 5 ticks. Good enough. Okay. So, whenever the small trigger gets close to the large trigger, right, we have an output here. So we've detected this approximation here, right? So now, let's see, kind of the key step of a rejection is basically your indicator, right, moves up and then turns away, and then changes direction. So if an indicator is changing direction, that's a inflection. So we're going to grab the inflection here. Connect that up. And so in this case, I'm going to be looking at the small trigger inflection. So what I'm actually looking at is right this point right there where that small trigger, right, reverses direction, changes direction there. Alright, so let's change our indicator over to the small trigger line. And to get the small triggers, we need a setting of 20 and 5. And we're using the trigger lines like so. Okay, there we go. Let me scale this up a little bit there. Okay, so we have this right, this reversal point on the small trigger lines identified there. So next, let's just join these together with an AND node and see what we get. Alright, so we've got a couple of signals here. Let's kind of take a look at them. So yeah, this kind of looks like a, a rejection right there. There's that, yeah, this is the other rejection that we found. So, and we can also see that there's some signals that we need to filter out here. So that's alright, so we want to get rid of that guy because actually we can see that the small triggers they reversed, but they weren't like rejecting off of the large triggers, so we need to kind of filter that out. And let's see here. Well, once again, this comes down to discretion of what you consider a rejection, because the small triggers, let's see, the small trigger average line, right, which is the bottom one, the average line didn't actually break through, so that could be considered a rejection because they both didn't break through yet. So, so we may want to filter this out as well. right. Okay, so I've identified a couple of bad signals here that we want to filter out. So we'll work on. So next we had to kind of analyze this and see what's going on. Why does this not qualify? What technically about this? We can see this visually, and it's easy for us to see and comprehend. That's how our minds work. But now we have to break it down to the little individual components so that a computer can understand why this isn't a rejection. So let's see. One thing I can see here, right, is one thing both of these areas have in common is the large triggers are sloping down, right? So when the large trigger is sloping down, I actually need the small triggers to come up and reverse down. But over here where my triangle is, the small triggers actually went down and reversed up. So when the large trigger is sloping down, I guess what I can do is I can say I'm not interested when the small triggers reverse up, right? That's not a reversal, or that's not a rejection when the small triggers reverse up when the large trigger is sloping down. So I kind of need to use the slope of the large trigger as kind of a filter here. So if the large trigger is sloping down, right, I don't want this green long rejection signal there. Yeah, so I think we'll try that approach first and see how well that works there. So let me grab a slope solver. All right, connect it up, and so we're going to be looking at the small trigger line. Let's put that indicator in there. Alright, set our trigger line indicator up so that it's set to the small trigger settings. I'm sorry, actually, no. We're looking at the large trigger slopes. Sorry. Let's put that back like so. And so here's something that you'll kind of have to experiment with, whether you want to actually use the trigger line or the average line, to determine, which one of these slopes you want to use. So I'll just, let's see, now probably I'll go with the average line here. Yeah. Okay, so let me rename this. Is actually looking at the large average line, the slope of the large average line. There we go. Yeah. So as we look at BloodHound's output here, we can see that whenever the large trigger line is sloping up, it's gonna filter out just kind of like long rejections, and if the large trigger is sloping down, then it's gonna filter out so that we only see short rejections like so. So let's connect that into our AND node and see what we get so far. And alright, so far so good. Look at that, we kind of took care of those two unwanted areas there. So let's scroll through the chart and see what we get. Let's see, yeah, here's a couple of more rejections picked up. Interesting. Let's see. I'm reevaluating this area right here again. So, I can see that even though adding the slope of the large trigger got rid of this, however, that actually may not be correct because you may consider something, let's see, this actually could possibly be considered a rejection, because what could happen is, like, our small triggers could come up like right up to there, and and then pulled back. And so that actually could have been a rejection of the small triggers. And however, the large triggers were sloping up. Yeah, so let's see, that's not, yeah, we don't actually want to use that slope solver. Alright, so the reason why this was not a rejection is because the small trigger actually did break through there. Okay, so I think so here's kind of another way to analyze what's going on here. Yeah, my thought was that the slopes are opposite of each other, right? So the large trigger line slopes are going to be opposite of the large trigger line slopes, right? So for example, in this unwanted signal there, the large trigger and the small triggers, they're both sloping in the same direction. So that's why it's not a rejection, right? When you get a rejection, the typically what you see is that, right, the slope of the small is going to be opposite of the large. Let's see. However, that's not quite true in this case right here. Let's see. Maybe instead of using the large trigger average, just the large trigger might work. So maybe the large trigger moves fast enough where, because I can see right in here, if this, we're just speaking hypothetically here, if this was a rejection, if this actually did turn out to be a rejection here, I can see that the large trigger, actually here, let me put the indicator on top of the bars. There we go. That kind of helps. There. So I can see that the large trigger did actually start sloping down. It did actually reverse down. So maybe that will work. So let's change this from the large average to just the large trigger. Alright, so that, good. So this we still got a signal here. And we'll have to add another filter to kind of to filter out this because of the breakthrough. However, we did eliminate this one. So okay, so far so good. Alright, so we need to build another to filter out this signal here. We'll have to build another set of filters. So yeah, okay, so in order to get a short rejection, I can see that the small triggers have to be below both of the large triggers, right? So if the small trigger goes above both of the large triggers, then basically it did penetrate through, and that's not a rejection anymore. However, if the small triggers, like right here, if the small triggers is at least below one of the large triggers, then it did fail. It did fail and it did get rejected. Alright, so yeah. So I'm going to have to build a filter that detects if the small trigger actually breaks above both of the large triggers there. So let's scale this out, and we'll work on this area here and build that. Okay, so here's where a couple of these extra indicator comparisons are going to need to come in handy. So we're going to have to compare our large trigger, right? I'm sorry. We're going to have to compare our small trigger to both of the large trigger lines. So let's see. First, so let's compare the small trigger to the large trigger. We'll do that one first. So let's just simply set up our indicators first. So grab the large trigger lines, and let's see, we need this to be the small trigger settings, and we're going to use the trigger line, right? So remember, the trigger line is the faster moving average. Alright, set indicator B up to be our large trigger. Alright, so that's the settings for the large trigger. It's on the trigger plot. That's good. Okay, so if you look at the output of the solver. See how the solver gives us a long output when the small trigger is above our large trigger, right? So this long output, basically, right, it disagrees with this short output. So just the fact that, all right, our comparison solver, the fact that our comparison solver is missing or doesn't have a short output means that when we connect it into this AND node, it's going to filter that guy out. So if I connect it up like so, right, that filters it out. So, however, you know, we do need to do some other comparisons, because yeah, we do need to compare it also to the large trigger, because let's see, yeah, if you notice, right, the large triggers are sloping up, so the large trigger line is actually above. But what happens when the large trigger lines are sloping down, right? Then our large trigger line is actually the lower one. So we would have to compare our small triggers to the upper large trigger line, which this one is our large trigger average line. Right, so that's why we need to compare it to both lines, depending, because it's all going to depend if the large triggers are sloping up or if the large triggers are sloping down. So let me delete these here. So like in this example, right, our large triggers were sloping up. However, yeah, what about right over here, where the small trigger could have penetrated through, and that would not have been a rejection, right? So we would have wanted to get rid of this if the small trigger had penetrated, but it didn't. So we do need to, right? So this large trigger average line here which is on the bottom, right, which is lower. This is the large trigger average, which is actually up top. So that's why we do need to compare to both of those large trigger lines, depending on if the large triggers are sloping up or down. Right. So, all right. So I'm just going to build that solver here quickly. So this one is going to be the small trigger to the large trigger average line. So you guys have seen me do this a bunch of times, so I'm just going to whip through this, just get it done. This time we want the average. We're comparing to the large average line. So I'll change that. And so to actually detect, a total breakthrough both lines, I need to use an AND node. So both of these conditions have to be true. So basically what this kind of logic here, what it does is it tells me when the small trigger line has broken both of the large trigger lines. Let's see. I'm going to make a adjustment here to the trigger lines. So there we go. So now, I made the trigger line a little thinner than the average line. So now this should be a little easier to determine which one's the average line and which one is the trigger line here. So, all right, so I can see that there's a little problem that we have here. So, right, this circle was actually a good rejection here. And let's see. Problem is I don't have any output. There's no output there. So having no output would actually block this rejection here. All right, so that didn't quite work out as expected. Yep. All right, so I'm going to have to build a couple of different sets, let's see, of this logic. Yeah, give me a moment to kind of think this through. I'm trying to, let's see, I'm trying to think of how to, so what I need to do is figure out, this kind of what, right, this set of logic here. Yeah, so this group of logic here, it works when price breaks the large triggers. When the small trigger breaks the large trigger, it's kind of doing its job. However, it's not doing its job when the small trigger doesn't break. So I need to kind of figure out, how to get rid of this situation here where there's no output here. Let's see, I'm going to just test something out. I think maybe the XOR node might work in this situation here. Yeah, maybe this is working. So, right, our triangle area here, right, price breaks through both large triggers. I mean, it's not price, but the small trigger breaks through both of the large triggers, and there's no output here. And the good news is, right, the small trigger breaks one of the large triggers, but not the other, and I still have an output, and that's what I want, because this is still a potential rejection here, right? If the small trigger only breaks one of the large triggers, that's still a potential rejection. However, if the small trigger breaks both of the large triggers, then that's definitely not a rejection, right? It's broken, so there can't be any rejection there. And let's see, let me check back here. And alright, so we got a little problem here because this is actually a good rejection, but there's no output. So, not quite working as expected. Okay, I think alright, so I've come up with another solution here. Yeah, so I'm gonna build a set of logic that detects if the small trigger is inside, is basically in between both of the large triggers. Yeah, and so that should take care of this here. Or, like I said, there's usually multiple ways to do something. So, let's see, multiple ways to do something. All right, yeah, I'm going to go with actually this way. Option number 2, using the OR node here. Now this may be a little more complicated to understand, but it's going to use less solvers. So I think this is a better option because it's going to use less solvers here. So let's revisit the XOR node, right? So so the XOR node is working great. It's telling me when, right? It's giving me, an output here when the small trigger is in between the large triggers. However, if the small trigger breaks above both of the large triggers, or in this case here, if the small trigger is below both the large triggers, then we have alright, then there's no output, so that's problematic. So what I'm going to do is I'm going to build just another solver that, another solver that's just going to look to see if if the small trigger is below the large trigger. So in this situation, the small trigger is below the large trigger, and I can generate a short output here. So that would allow, right, that would allow this rejection here to pass through. And over here with this triangle, when the small trigger is above the large trigger, it would generate a long output. And so once again, since it's generating a long output, it still would not allow this short signal through, because this was not a rejection. Yeah, so I think that's going to work in both situations here. And let's see. So actually, I already have a solver here that does that. Yeah, so looking at this solver, right? Interesting enough, so I can see when, right, the large trigger breaks, the small trigger breaks above the large trigger, it gives me a long output, right? So remember that long output disagrees with the short output, so it would actually block this short output. And going back over here, right, I'm getting a short output from that solver, which agrees with this rejection here, this kind of short rejection. So so what I need to do is I need to take this guy, pass it through, and also pass the XOR through. Now let's take a look here. Alright, so remember, this is just a filter. So all these guys are just, trying to filter out whenever the small trigger, breaks the large triggers. To see if we actually broke the large triggers, which is not a rejection, or if it failed to break both the large triggers, which is a rejection. So so we get a short output here, which is good. That would allow that short rejection through. Right. So keep in mind, what we're trying to do is we're trying to build a filter for what we've built so far, this AND node, what we built so far. So since this is a good signal, we need this filter to output at least a short during this good filter. And and we need this filter, right? So we need this filter here to not have a short output right here. So if this filter is missing a short output, then it's going to block the short output. But since this is a good rejection signal, that filter needs to have a short right there. So let's just mark these guys. So I'll put a diamond there. So this is the bar that the filter needs to be missing a short output, and this is the bar where we still need a short output. So let's take a look here. So as we look at the chart, right, so this bar, it does have a short output. So that filter would allow this, this good signal through. Looking over here, I can see it's missing a short output down here. So that would block this. So let's take a look. Take that, connect it into the anode, and there we go. So, all right, so this is not a rejection, and so there's no signal there anymore. And let's see, yeah, we had taken care of this earlier with another solver that filtered, right, that filtered that signal out. Alright, so we still have both of these good signals here. Both of these good rejections. Alright, so now I just need to scan through the chart and find some other places here. So, yeah, look, there we go. So it found a couple of more areas where the small trigger basically kind of bounced off of the large trigger. Didn't break it, didn't penetrate it, but bounced off. And oh, look at that, interesting. So yeah, because we get looks like because price reversed there on one bar. Interesting, we got a 1 bar reversal, and it did actually take our small trigger and reverse it up for a rejection. So interesting. All right, there's a good rejection. So this one, I can assume that this was too far away. This is, yeah, more than 5 ticks away. So this didn't get identified because it's more than 5 ticks away. Let's see what we got here. Yeah, we did get a bunch of rejections inside, so the small triggers kind of moved inside and kind of flip-flopped around inside, creating some rejections in there. And okay, so look at here. I did find, yeah, so right here, this actually is not a rejection. Right, the small triggers actually broke through. All right, so we have to find out why this short happened. Oh, all right. So I can see what happened here. So remember, I took our our filter here, and I plugged it into results nodes. That's what we're looking at now. We had to look really closely, but I can see that what happened is, let's see our small trigger line here. Right, it did break through up, but what happened is when the bar reversed down, right, the bar reversed down, which also caused the small trigger to reverse down, and the small trigger just barely went inside the large trigger. So I'm actually looking at the small trigger right on the bar, after, on the bar after this reversal down. So I think what I need to do is look at the small trigger back one bar, back here at the at the bar where it actually reverses down. All right. Alright, yeah, so I think what I can do, I think this will work, I'll just have to test it out, is I'm going to take this filter here and basically, let's see, yeah, delay it or shift it one bar. So I'm going to use the look back node and use a displacement of 1 here to shift it, and see if that works. Alright, so it at least got rid of this signal here. And let's make sure it didn't get rid of any good signals. So I'm going to go back to the beginning of the chart. And alright, so good. We got this rejection still, that's good. Alright, we got this one, that's good. And these are still filtered out, so that's good. So far, so good. Let's see. Yep, this was a good one. Yep, that was a good one. Yep, technically this was a good one. Not ideal, but you never know what price is going to do. So you can't filter them all out, because that is the randomness of the market. All right, that one's good. That's a good classic, I think. I think that's a good classic rejection there. Yeah. All right. So using a displacement of 1 seems to be working good. So we did get rid of just that one. So it looks good so far. And yeah, interesting. Yep, so we got two little rejections there. Alright, so that looks good. Yeah, that one looks good. Well, actually, yeah, this is actually correct. Interesting. Let's see. I'm going to take a look at the small trigger inflection. It's hard to see, but there is, alright, I have to scale it way out, but look at that, there is a little dip in that small trigger right there. So, right, I'm just looking at when the small trigger inflects, or, you know, changes direction. And so right there, there is a little dip in that. Yep, so there was just a small enough inflection in that small trigger to generate a long rejection there. Let's see, yep. I'd say that looks like a good one there. And yeah, interesting. That we got a little, we did get a little rejection inside, but then price reversed on us again. It didn't follow through. So, all right. So, Asif, there you go. And it looks like I had an extra comparison left over. Let's I'll delete that guy. Don't need it. And I'm going to delete this unused comparison solver off the board here. All right. Okay, let me see what else we got. Armando would like to see how to take a signal and essentially extend it forward in the same direction. So, let's see. All right, Armando. Let's see. I think we were working with this 4 up bars and 4 down bars. And let's see, I need to put this on a range chart again. Oh, actually, you know what, those Renko bars actually worked out really good for that 4 up and 4 down. So let me put it back on those Renkos there. Okay, so there we go. We just, you know, we have some signals on the chart, just as an example there. So, if you'd like to extend a signal forward, all right, so if you're, let's see, some solvers like this is an inflection solver. Some solvers have this look back period, which in a sense allows you to extend a signal forward or an output forward. You know, obviously and nodes and or nodes, you know, logic nodes don't have a way to extend the signals forward. So what you can do is just use the signal extender, like so. All right, so the easiest way to extend a signal forward is you can use the signal extender, like so, right? And the signal extender defaults to 5, like so. So you can see now it's extended it forward 5 signals. So now the signal extender, you know, it has a bunch of, you know, reset options here. So you can actually turn the signal off early if you want. So you can prevent or stop the signal from extending 5 bars early, you know, by using these various reset conditions. So, so this is a more advanced way of extending a signal forward. If you just want a simple solution, let's see. I'd use the look back as a simple solution for that. The look back, I think, the look back, I think it, it doesn't use quite as much processing power as the signal extender, right? The signal extender has all these resets, so, that's a few more calculations that have to be done. So the look back, using a simple solution, if I wanted to use the look back, I set the displacement to 0 because we don't want a displacement, we actually want to use a look back. And I'll set that to 5. And now the mode here, what I'm going to do is I'm going to set the mode to max, like so, right? So with the mode set to max, I can see now I took the signal from the AND node, and I'm using a look back of 5. So basically, this look back of 5 now is kind of this. It's exactly the same thing as what some of these solvers are doing when the solvers have this look back period. So this look back node setting the mode to max is doing the same thing as what the solver's doing, right? So it's finding any signal coming out of this AND node. It's finding any signal coming out, and it's looking back 5 bars to see if there's one, which is the same thing as basically saying extending a signal forward 5 bars. Right? So there you go, Armando. Hope that helps. All right, with that, guys, I will wrap it up today, and I hope you guys have a good weekend. See you guys next Friday, I hope. All right, thanks, guys.